Hello, everybody. Welcome to another day of math. Everybody's favorite, right? All you many students watching this. So, today we're going to be talking about stories and graphs. Basically, we're going to be looking at a graph, and we're going to use it to interpret some things about what's going on. First of all, this is our graph right here. It's talking about Amy and Sarah, and they went for a walk, a crawl or something. Basically, the graph is measuring on our y-axis distance in feet. So like this would be like their starting point, their house or whatever. And the farther up they go on the y-axis, the further away they get from their house. And they're trying to meet each other at the store. So their goal is to meet each other at the store. Okay, and then we're measuring time in minutes. So notice time is in minutes, distance is in feet. They go, store's 100 feet away, so it doesn't really take that much time. Or I mean, I guess it does take a lot of time. It's just not that far. I mean, think about 100 feet, football field is 300 feet, so a third the length of a football field. So yeah, that kind of tells you how fast Amy and Sarah are. Let me look at this graph. Okay, but basically, I mean, it doesn't matter how fast they are. They do some things that we can interpret and see when they're moving quicker or slower and stuff like that. Basically, if we're looking at these lines, the shallower the line is, the slower they're going. And if it's a completely flat line, that means they're not getting any further away from the house. They're not getting closer to the store, right? So that means they're basically stopped. Nothing is happening at all there, right? And then the steeper the line is, the quicker they're moving. They're basically running. Well, running as much as you can, comparatively to what they've been moving before, I guess. What we should say. So by using this graph, we're going to we're going to answer some information using that graph. So first thing it wants us to figure out is how far away from the store is Amy at the beginning. So Amy is our solid line right here. So that's our solid line. So Amy starts at 0, and it's just asking how far away she is, right? So we're going to look at distance. So the distance to the store, looks like if this is the store, that's at 100 feet. So if that's at 100 feet and she starts at 0, she is 100 feet away. Okay, it's pretty easy to see that, right? Not too difficult, just reading the graph. Okay, let me zoom out a little bit so I don't have to keep sliding it. Sorry if that's hard to see, but this is in your book, so you can follow along in your book if you can't read what's on the screen there. The next thing it asks is how far from the store is Sarah at the beginning. So Sarah is our dotted line. So store's at 100 feet, right? Sarah starts at 30 feet. So how far away is that? Well, you think about 30 feet. Take that away from 100, that would leave 70 feet to go, right? So Sarah is having to travel 70 whole feet to get to the store. I know it's a long distance. It does take her like 26 minutes to get there. So she must be tuckered out by the time she gets there. Okay? And then how long does it take to get? So I just answered that. It took them both 26 minutes to get there. 26 minutes, not seconds, minutes. Because it's measured in minutes, right? So 26 minutes. And then it asks what happens between 6 and 7 minutes. So 6 and 7 minutes, what's happening right here? So this is the time right here, right? But that's where the time is on the x-axis. We need to look at what's happening at our lines. So right here is right at 7 minutes. So what's happening right there? Well, that means they're both the same distance away from the store. They could have just, high-fived each other on their way. Or they could be like coming from opposite directions. So who knows? All I know is that they're exactly the same distance away from the store. So they're the same distance from the store. But then Amy's hustling and goes much quicker and stuff like that. So now it wants to know where Amy's moving faster. So again, I kind of talked about this already. Basically, you're looking at which line is the steepest, because that's going to be when she's moving the quickest. So looking at Amy, it looks like she goes, let's focus on this line first, because she's got two steep lines here to look at. I can kind of eyeball and see which one's quicker, but if we look at it here, she starts at 10 feet and goes to 50 feet from 4 to 8 minutes. So that's 4 minutes it took her to go 40 feet. So if you think about it, that's like 10 feet per minute, right? And then if you look up here, she starts at 60, goes to 100, but it takes her from 20 to 26 minutes. So that's 6 minutes difference. So that is going to be a little bit slower, right, than the 10 minutes per minute. So you would say for this one, it'd be between minutes 4 and 8. So between minutes 4 and 8. And Sarah's moving fastest. If you look at it, she really only has one steepish line, and it's this one right here. So she goes from 70 to 100 in 6 minutes. Right? 1, 2, 3. Yeah, they're going. Yeah. So 6 minutes. So she goes 30 feet in 6 minutes. So that's 5 feet per minute. So that's her fastest. Next closest would be this one right here, but that's a little bit slower. So where is she moving fastest? That'd be between minutes 20 and 26. And 26. Now, here's the important part. What is the speed of Amy between 4 and 8 minutes? So I already kind of touched on that. But basically, when it asks for the speed, when we're talking about distance and time, it's just wanting me to find the slope. So to find the slope between 4 and 8 minutes, you build the ladder to go up the ramp, okay? So between 4 and 8, that moved 4, so that's a plus 4. And then from 10 to 50, that's a plus 40. So that would be 40 over 4, or 10 over 1, which means 10 feet per 1 minute is what that's saying. And then the speed of Sarah from 8 to 16. So Sarah's the dotted line. So 8 minutes to 16 minutes. Again, you do your ramp to go up the slope. 8 to 16 would be 8 minutes. And then she starts at 40 and goes up to 70. So that's a plus 30. Okay. So that would be 30 over 8. So 30 feet per 8 minutes. And we can simplify that, right? So again, calculators will do that for us. If we just do 30 fraction button 8, that'll simplify it to 15 over 4. So that's 15 feet per 4 minutes. And we could also simplify it to a per 1 minute just by finding the decimals. 30 divided by 8 would be 3.75 feet per 1 minute. Okay? So there's lots of ways you could do that. Okay? And then average speed for the whole trip, you're just doing the slope for the entire thing. So you'd start at the bottom, goes 100 feet in 26 minutes, 100 over 26, and you'd simplify and stuff like that. And that's basically all you're doing with these stories from a graph.